In order to understand this video, you should watch the following videos: the Blender Node Insanity Made Sane video, the 2D versus 3D texture video, and the space-time manipulation part 1. Okay. If you have not learned the knowledge in the previous videos, then you will have a hard time understanding the terms that I will be using in this video. Okay, I'm not gonna spend time explaining things that I already explained before. In the last video, you learned how you can transform space uniformly, okay? And in this video, you will learn how to transform space differently depending on where you are in the space, okay? So as it turns out, there is no set of rules to guide you how to do certain things a certain way. Instead, you have an end result that you want to achieve, okay? And you will have to figure out a set of rules that generate that kind of result. It's actually easier than it sounds, really. It's easier than math, because if you're in high school and studying math, then you can see that they give you a math problem and they ask you to solve it. But here we already have the result, and we have to figure out the math problem that leads to that result. So because of this reverse nature of doing things, there can be multiple ways to achieve the same result. So for example, if I give you a number 12 and I can tell you to figure out the math that result in the number 12, you can figure out a bunch of different math that give you the result 12, right? So 6 plus 6 equal 12. You can also say 12 plus 0 equals 12 as well. Or you can also say 4 multiplied by 3. So all of these operations have 12 as the result. And similarly, the node editor is pretty much the same. You have to decide an end result that you want to achieve, and you figure out the bunch of math that leads you to that result. No matter how you implement the math, if it produces the same result, then it works. Now, one math operation may be faster than the other. The 12 plus 0, for example, is the fastest operation that results as 12, right? And 4 by 2 multiplication is probably slower. So similarly, in the node editor, you can figure out multiple ways to do a certain thing, but sometimes a certain way is more optimized and faster. Look at this pattern, for example. What kind of rules do you see in this pattern? Okay, so there are actually two ways, at least two ways you can see this pattern, okay? The first way is a bunch of straight lines, and the lines were pushed up like so. The other way to see it is that these are a bunch of straight lines in the center, and the lines are pushed up and down and up and down, okay? Both ways achieve exactly the same thing, but the first way is a bit faster since we only push up and not push down. Now look at this checker pattern, for example. What kind of rules do you see in this pattern? The way I see it is that these are a bunch of black and white vertical lines, and for every alternate horizontal lines, the vertical lines are inverted, okay? Another way I can see it is that these are a bunch of black and white vertical lines, and for every alternate horizontal lines, the vertical lines are shifted to the right or to the left. Now both ways will create exactly the same pattern, but since this video is about space-time manipulation, we will focus on the second way of doing this pattern, okay? So you can see that the transformation of the space is not uniform across the entire space. We don't move everything to the right, but we only move this line and possibly the line above it. So now we can break down this even more, in order to move every alternate lines to the right, we have to somehow use the y dimension to do that, okay? Because you can see that the change is uniform along the x-axis. Every point on this horizontal line is being transformed exactly the same. But the transformation change over the y dimension, that means that we have to use the y dimension somehow to dictate the transformation. Okay, so let's go ahead and do that. And let's delete the checker pattern and create a texture coordinate node, and let's use the generated texture coordinate. Let's get rid of the z channel, use a vector math node and change the operation to multiply, and set the x and y value to 1 and the z value to 0. This will basically get rid of the z dimension for us. Okay, so let's focus on 2 dimension for now. The same math can apply for the 3D textures using the same techniques. Okay, now that we have a 2D space, let's try to create our checker pattern. So as I said before, we have to use the y dimension to somehow control the transformation of the space. Okay, but first let's try to create a bunch of black and white vertical lines. So in order to understand what I am about to do, you have to watch the Node Insanity Made Sane video, and I'm not gonna try to explain what I have already done in that video. So I'm gonna speed up this video now. Alright, now we have vertical black and white lines, like so. And I can change the scale over here to change the size of the lines. For example, I can set this to 10, and I now have 10 vertical lines, 5 black and 5 whites. Okay, and the width of each vertical line is exactly 1 unit. So now let's push every alternate lines to the right, and since the change is along the y dimension, we must use this y value somehow. Okay, let's copy these nodes and maybe copy this node as well, and this gives us these alternate lines. Okay, as I said before in the Node Insanity Made Sane videos, these are actually just values, and we can use the values for whatever purpose we may have in mind. And right now in my mind, these are the values of the distance of movement along the x-axis. Okay, so here the x-axis is moved by 0 unit, and here the x-axis is moved by 1 unit, and here's 0 and here's 1, like so. So if we transform the x-axis using these values, we should have the checker pattern. Okay, so let's copy this math node, like so, and we add the values to the x-axis. Remember the last video I said that by adding and subtracting the values from the coordinate, we basically translate the coordinate. Okay, so by adding these values to the x-axis, every alternate lines along the x-axis is shifted. Okay, and as the result, we have this checker pattern. Okay, so this is adding 1 and 0 to the x-axis. However, we can add different values. For example, I can add 0 here, but here I want to add, let's say, 0.5. Okay, so let's just multiply this by 0.5. There we go. So here this region is still 0, okay, and here we have 0.5. So let's try to add that to the x-axis to see what happens. You can see that every alternate lines are being moved to the left. Okay, So we can change this to subtract to move everything to the right. There we go. And you can change these values to change the distance of transformation. So what can you take from this texture? So you can see that if the transformation is changing along a certain axis, then that particular axis must be used somehow in deciding the transformation. Okay, if you see the transformation is not uniform along the x-axis, then the x-axis must be involved in the transformation somehow. Okay, so let's take a look at the other texture. Alright, so first things first, we need to create the the horizontal lines, right? So use the fraction math and create a color ramp node and bring down the white key and maybe set this to constant. There we go. Maybe let's make it a little thicker. There we go. So now we have a bunch of straight lines, and now we have to create some sort of push up. The distance of the push up is not uniform along the x-axis, so that means the x-axis must be involved somehow in the transformation. Okay, and you can see that we have repeating changes along the x-axis. That means a modulo math or a fraction math must be used somehow. So now we have this repeating pattern. Okay, and copy this color ramp node and bring the white key to the right, not the right, to the center, and change this to the linear method and create a black key to the right. There we go. Alright, now we have this black and white pattern, and again these patterns are just values, and over here the value is 0, and over here the value is 1, and here is 0.5. So we can use these values to transform the y dimension. Okay, so let's just add this to the y dimension. There we go. Now we have this uneven transformation along the x dimension. Over here we have no transformation. Over here we have no transformation, and over here we have a push down transformation. So we can force it to push up by changing this to subtract, and now we have this push up. Okay, and again we can also add a multiply node. Not there, place it here. A multiply node to dictate the distance of travel. Okay, so here is 0 to 1 transformation, and by multiplying every values with 0.5, now the maximum transformation is 0.5 unit, and as a result we have this kind of lines. And again you can change this value to dictate how much push up and down you want for the pattern. Okay, so what about the thumbnail where I make a curved transformation? So if you have watched the Node Insanity Made Sane video, you probably know what I'm about to do. We can add a curve transform to transform the linear gradient to something different, and we can add this curve to make the transformation a roundish kind of curve like this. And you can also add an S kind of curve to make an S kind of transformation like this. And again you can add a multiply math to reduce the distance of transformation. There we go. So this over here, this is supposed to create a bunch of straight lines, but since the space itself is curved, the result is a bunch of curved lines. And if you are to be inside this space and you walk along this line, you will see that everything is still straight. But from the outside we can see that the space is curved and the lines are curved, and your walk path is not straight. Okay, so these are basically a bunch of straight lines in a curved space. This is the very simple technique to use one dimension to control the transformation of another dimension. We can also use a texture to transform our space. And that brings us to the second part of the video, the texture transformation. Okay, so this is our space, and we can use this space to create, let's say, a noise texture. Not the white noise, the noise texture. Where is it? There we go. Now you can see that the noise produce a 3-channel kind of result, the red, green and blue. And we can use the red, green and blue as the values to transform the x, y and z dimension. Since we are dealing with 2D space, let's go ahead and get rid of the z dimension of this color output. Okay, now the color and vector are basically the same. They're just a set of 3 channels. So you can use the multiply vector math node, or you can use the mix RGB node and change the operation to multiply, and multiply with b to 0 and red and green as 1. This will be exactly the same. Okay, so let's create the vector math node and set the operation to multiply, and these for x and y we set 1 and z is 0 to get rid of the z dimension of this color output. Okay, so now we can use this to transform our space. Okay, so create another vector math node and connect this this space to the first slot and connect the texture to the second slot. Now we have a completely distorted space over here, and if we use this space to create, let's say, a checker pattern like so, we should have a completely destroyed space. So this is the checker pattern in a curved space, and it looks like this. So we can actually multiply this with let's say 0.05, and now the transformation is less severe, and you can see that the space is slightly distorted. So let's create an input value and use the same value for all the 3 channels. And since the z channel over here is zeroed out, it doesn't matter anymore. So this value will affect the x and y values of the texture. Okay, and we can change this slider to change how much it distorts the space. And you can see that as I increase the value, you can see that the texture seems to be moving diagonally to the bottom left. Okay, and I don't want the entire texture to move like so. I want the texture to be distorted but not move. Okay, so how do I come about doing that? So if you look at the values coming out of this node, you can see that, let me just add a separate XYZ node. You can see that the transformation is in the range of 0 to 1, and 0 being no transformation and 1 being transforming to the bottom left. Okay, so we need to transform up and to the right as well. The way we do that is to force some of these values to negative. Okay, so let's copy the multiply node and change this to add. Not add, let's change it to subtract, and subtract 0.5 from the x and y value. And now let's create another separate XYZ node and visualize it. So you can see these black areas, these are negative values, and these regions will transform the space to the top right. Okay, so let's get rid of the separate XYZ node and let's see the end result. Okay, so now as I increase the transformation value, you can see that the space is kind of distorted, but the features seem to stay exactly where they were before. Okay, and you can change the scale of the noise in order to change how the space is transformed, like so. So let's create, let's say, a Voronoi texture, and let's see what's going on. And now we have something that looks like this, and this is particularly useful when you need to create some sort of natural looking texture. Okay, and let's reduce the transformation a little, like so. Now we have this kind of Voronoi. Okay, so this, I call this technique the space warping technique. And remember this technique because in the future we will be using this technique all the time. Anything that requires some, some random distortion involve this kind of technique. Okay, so basically we create a noise. We get rid of the Z channel if we are dealing with 2D texture, but with 2D texture we can just get rid of this node and just subtract 0.5 from the color and send this to a multiply node to dictate the intensity of the transformation, and then we add it to the original space, and here we get the distorted space. And then we use this distorted space to create a texture. Okay, so from the perspective of the texture, if you are to be in the universe of this texture, you will not see any difference. Okay, but since we are outside of this space, we see everything as distorted.